Alright, so today we are starting algebra. So first of all, let's just talk about the word algebra and algebraic expression. So if we look to the word algebra, the word algebra is actually derived from an Arabic word, and that Arabic word is algebra. Algebra, and the meaning of algebra is reunion of broken parts. So if you write anything in mathematics, let's say any operation, that operation can be addition, subtraction, multiplication, division, or anything else. So let's say there is 2 plus 3. Now this 2 plus 3 is actually a mathematical expression. If I write 4 times 2, it's a mathematical expression. If I write, let's say, 5 divided by 4, it's a mathematical expression. And let's say 3 take away 2, it's a mathematical expression. So all of them are mathematical expressions. So what's an algebraic expression then? An algebraic expression is, we can define it like this, that such an expression in which constants, now what are constants, we will discuss that, in which constants and variables are connected with the help of algebraic operators, or we can say terms. Now what is constant, what is a variable, and what are terms, and also what are algebraic operators? We need to discuss that first, and then you can get the meaning of the algebraic expression. Alright, so first of all we need to discuss what constant is. What is constant? So let me write it here. Basically we define constant as a quantity that has fixed value. And in algebra, I mean the numbers. So numbers is the constant quantity which has the fixed value. Like if I say 2, so 2 means only 2, 4 means only 2, 4 in each and every equation, in each and every expression, 4 will be always 4 and 2 will be always 2, and all the numbers, they will have the same value. This cannot happen like if in one equation 4 means 4 and in the other equation it means 3. You getting my point?
Yeah.
And then the other one is a variable. So what's a variable? A quantity that has not fixed value. Like in algebra, mostly we use x, y, and z as variables, but we can use from A to Z all the alphabets as a variable. We can choose any letter as a variable. And now to understand more the concept of a variable, like the word variable is derived from variation, and variation means change. So it's a quantity that changes, which is not fixed. Let's just take an example of a bucket. So let's say there is a bucket and I named it X. Now what do you think? What can you put into this bucket? What can you pour into this bucket? Name anything.
Water.
Just water?
Yeah.
Alright. So if someone asks me the same question, I can say pebbles, I can say sand, I can say clothes. I can name anything that fits in this bucket. And now let's take an example of numbers. So let's say I'm writing here a number -3. Now I want you to write a number in the bucket.
Okay. I'll do. Oh.
That's right. Now let me write a fraction. You can write a fraction as well. Right? Go on, write another number.
Could it have a whole number, the fraction?
Yes. You mean the mixed number?
Yeah.
Right? It can have a 0 as well. Go on, write a number. +3, that's right. It can have a negative fraction as well, like -1/2, or it can have a number like this also, like 5 under the root. And that's enough for this example. So this was just to show you, and it can also has a number like in decimal, let's say 3.1. So this was just to show you that this bucket now contains different numbers: decimal, proper fraction, and let me write improper fraction here, mixed number, positive fraction, negative fraction, positive number, negative number, 0. So what I'm trying to say is that variable can be anything. If we are giving a value to a variable, so we can give any number we want. And if we are finding the value of the variable, then it can be anything, like in one expression or in one equation, x can be 1, in the other equation it can be 2. In the third equation it can be like a negative number. And in the fourth equation it can be like a fraction. And x is just still the same x. Like this is the bucket, let's just empty the bucket and put some more numbers into it. So that's the example. So now it's the same x, but this time it will have different values. So that's the concept of a variable. That variable is not, that's a quantity that has no fixed value and it changes. Like if I write here x plus 1 equals 0. So now you tell me, what should I add with 1 to get 0?
If you need 0 and 1, you still get 1.
It's a very simple example. Let me tell you, it's -1. So if we add -1 to +1, they both will cancel out and result in 0. Or you can say it the other way around, like 1 take away 1 is 0. So now let me write another equation in which it's the same x. So let's say this time now it's x plus 2 equals 3. So now what should I add with 2 to get 3?
1.
That's right. So here x has the value 1. See, now it's the same x. In the first equation it's -1, and in the second equation its value is 1. So that's the example of a variable, that it changes, it's not constant. But the 1 is always 1 in every equation. Here 1 means 1, here 1 means 1, here 2 means 2, and in other equation 2 will also mean the 2. So numbers don't change, that's why they are constant. And variables do change, and we represent variables by letters, and mostly small letters. Getting it?
Yep.
So in the definition, I said such an expression in which constants, which is clear now, we have defined it, variables, which is also we defined it, and it's clear now, are connected with the help of algebraic operators and terms. So now let's discuss algebraic operators and terms, and then I will give you the example of algebraic expression, and then you will get it. So first of all, algebraic operators, that's very easy. Okay, so algebraic operators are also called arithmetic operators. That's another name for it. And they are just plus, minus, multiply, divide, which you already know. This is just the terminology that you need to remember. And now, what are terms? Let's discuss the terms now, because there is something we need to discuss. So an algebraic term on every plus or minus sign term terminates. Let's look at an example. Let's say x plus 5. So as I told you, on plus sign term terminates. So here is the plus sign. So that means that here in this expression we have two terms, one x, one 5, because on plus sign term ends. Terminates means ends. Let's look at another example. Let's say now we have 2x squared plus x minus 1. Go ahead, now you tell me, how many terms do we have in this expression?
And we have 1, 2, 3, 4. We have 5.
5. Alright, so you just need to look at the plus and minus sign. So one plus sign is here and one negative sign is there. So the first term ends here, the second term ends here, and this is the third term. So we have 2x squared as our first term, x as our second term, and negative 1 as our third term. Now explain your idea how there are 5 terms.
I done. This is one term. This is the other term. This is the other term. This is the term, and that is the other term.
Alright. Then we need to refer to the definition. In the definition it says on every plus or minus sign the term ends. So we just need to look at the positive and negative sign. Okay. Now another example. Let's say now there is x power 3 plus y plus x plus 9. Okay, now tell me how many terms are there?
1, 2, 3, 4.
4 terms, exactly. It's clear now, right? It's easy.
Yeah.
Now the next thing you need to know is like and unlike terms. That's very important. So we just differentiate between the like and unlike terms according to the variable and power of the variable. So I will just simply write p and then hyphen then x, means power of variable. So if the variable is x, then power of x. If variable is y, then power of y. Let me show you an example. Let's say we have 5 and the other term is x. Now look at these both. This one has this term has a variable, that is x, and this one has no variable. It just has a constant. So these both are not like terms. These are unlike terms because they're both different. For like terms, there needs to be the same. Like if I write 3 and 2, now they're both numbers without variables. Now these are like terms. And if I write x and y, they both are also unlike terms because variables are different. That's true that powers are the same. So we just don't look at the powers. We also look at the variables. Variable also needs to be the same. And if variables are the same but powers are not, still they are not like terms. Like one is x, the other one is also x, but this one has power 1 and this one has the power 2. So now variables are the same, like the letters are the same, x and x, but they got different powers, 1 and 2. So they are both like terms, right?
No.
That's right. So you are active, that's good. Yeah, they are unlike terms because powers are different. That's good. So that's how we differentiate between like and unlike terms. And why do we need these unlike and like terms? They help us in addition. We can only add like terms. Like if we have x and 3x. Now, you tell me, are they both like terms? What do you think?
They're unlike terms.
And why?
Because one has the number 3 and the other one doesn't.
Alright, that's true. But to check for like and unlike terms, we just look at the variable and its power. So here we have the x variable, here we also have the x variable, here the power is 1, here also the power is 1. So they are both like terms. And you just need to remember this. 3x squared. Let's say. So this 3, which is in multiplication with the variable, is called coefficient. It's called coefficient. What's coefficient? Coefficient is a number in multiplication with the variable. And what is that small 2 over there? So first of all, whenever a number is small written on the top of a number or a variable, so the place is called superscript. What is it called?
Superscript.
Superscript. And whatever we write in superscript is called power, or you can say exponent or index. It's the same thing, it just got 3 names. You can call it power, you can call it exponent, or you can call it index. All the 3 names are correct. What do you call it in your school?
We haven't really started this one, so.
Alright. So power, exponent, or index. And then this x is the variable. Or in case of a power, so the number or the variable that has the power, then at that time that number or that variable is called base. So base is something that has the power on it. It can be a number or it can be a variable. A number or variable that has a power on it, or index on. Index is actually a singular word, and indices then a plural word. Indices. You might have heard the word indices. In UK they use it
yeah.
the most in the school. So indices is the plural, index is the singular. So index, exponent, power is the same thing. Alright, now let's look back at the definition. Follow my mouse here. Now let's discuss each and everything here in the definition. So, such an expression in which constants? So what are constants?
A quantity that has a fixed value.
Like?
Numbers.
Numbers. And what are variables?
A quantity that doesn't have a fixed value. Example, x, y, and z.
That's right. Are connected with the help of algebraic operators, or you can say terms. So what are algebraic operators?
Is it the same as terms, like the meaning of terms?
No. So the plus, minus, multiply, divide, they are the algebraic operators. Here I wrote it.
Oh, yeah, sorry.
They are the algebraic operators. And what's a term?
A term is on every plus or minus sign term terminates.
That's right. Now let's write an algebraic expression. I have wrote many algebraic expressions during the examples and during while like I was explaining constant, variables and terms. So let's write now, let's say 3x plus 5. Now 3x plus 5 is an algebraic expression, and if you look at this expression, it perfectly fits on the definition. 3x plus 5. X is the variable, 5 is the constant, and they are both connected with the help of this plus sign. And it's an expression, and it's an algebraic expression because it involves variables. So an expression that involves variables are called algebraic expressions. Got it?
Yeah.
I could have simply said this before, that an expression which involves variables are called algebraic expressions. But I wanted to discuss what constants are, what variables are, what algebraic operators are, what terms are. So now these are the operators and the operations. Let's just quickly talk about this briefly. So operations and operators. So there is an operation called addition, and for addition we use the plus operator. So plus sign is just an operating sign. The operation is called addition, and similarly like that. This is subtraction. Let me just type in quickly. So subtraction, multiplication and division. Operators, you can call them operators or operating sign. Got it?
Yeah.
Any question?
No, not really.